Welcome to Algorand Developer Office Hours. I'm your host, Russ Festino, Developer Advocate here at Algorand, joined today by guests Ian Cross and Jason Paulos, colleagues here at Algorand on the product and engineering teams, respectively. Today, we got a killer session on learning about connecting your dApp to the official Algorand wallet for native mobile signing capabilities. So without further ado, Ian and Jason, take it away.
Yeah, my name's Ian Cross. I've been at Algorand for a couple of years now, I guess since I joined before we launched, so that was an exciting time. I started out working on the core protocol with the core protocol engineering team. The wallet was at the time sort of a side project, but as the wallet has grown and we've added new features and gained a lot of traction there, I've been focusing more of my time on that. Today, I'm going to show you this feature we have upcoming about WalletConnect. But before I do so, let me pass it off to Jason. Jason, you want to introduce yourself?
Sure. Hi, everyone. I'm Jason. I'm a software developer here at Algorand. I joined a little over a year ago. And since then, I've been working a lot on our kind of developer-focused libraries, APIs, and SDKs. So if you make a GitHub issue, I probably will see it and respond and help you out if I can. And yes, I'm also really excited to show you some of the stuff that we have today.
Awesome. I'm going to start by going through some slides. I know the dreaded slides here, but hopefully this will give you guys an idea of what this feature is. And then Jason's going to go over the much more exciting demo at the end. So let me present here. Again, my name's Ian. We're going to go through the Algorand Wallet, this new feature with the Algorand Wallet, and it's all about integrating with this WalletConnect protocol. So here's a quick outline. What is WalletConnect? What is the sort of state of transaction signing in the Algorand ecosystem? And then I'll go through a user flow and what that might look like in an actual app or dApp, decentralized application. And then I'll talk about the transaction types that are supported, and then we'll jump into the demo. Okay, so before we begin, I just wanted to point out a couple of things. One is that this feature is still in development. We're planning on launching it mid-August. And currently, we'll show you in the demos that we've got prototypes and we've got some example code and things like that, which enable you to really quickly get up and running with this functionality. But I do want to say that there are a bunch of convenience functions and abstractions that we're building into the Algorand SDKs, which will make it even easier. So just keep that in mind. If you look at the code and you're like, oh, this is more code than I want to deal with, it's really going to be simplified, and you should really only need to think about it from here's my Algorand transaction, here's how I communicate with this server. Again, we'll get into all of that, but I just wanted to mention that up front. And then the third thing is, we'd really love to collaborate with you guys. Happy to spend one-on-one time if you're building a dApp and you think that this is the right feature for you. So with that, let's talk about the current state of signing transactions in the current Algorand ecosystem. So right now, Algorand dApp developers really only have desktop signing options, which those options themselves are awesome, and kudos to those teams who have done that. But it's difficult for a dApp currently to reach mobile wallet users. Obviously, we're going to be talking about this through the lens of an Algorand Wallet user. So if you were trying to get an Algorand Wallet user to sign a transaction to confirm something, you might have to tell them, okay, you need to download this additional extension. Maybe you need to download this other app, and then you might have the Algorand Wallet user saying things like, does my Algorand Wallet work with this? I've got my account here. How do I get that to correspond with the app, basically? Yeah, so basically the gist of this is that it's not easy for you to interact with an Algorand Wallet user on their phone, and hopefully that's where WalletConnect comes into play. So what this looks like is, so what is WalletConnect? And I've just copied in this screenshot from their website, which I put on the bottom right. I encourage you guys to go check it out. But basically, it's an open source protocol for connecting your dApp with your phone. And basically, it's as simple as that. It's via a QR mechanism that a phone would scan, and then there's a connection between this computer and this mobile phone, ideally, or I guess just desktop versus mobile. And then at that point, requests can be sent from the dApp to the phone, to the mobile wallet to be signed. So I'm not going to go through everything, all of their code right now, but it's open source. You can check it out at that website. Maybe someone can post a link to it in the description just so people can click on it. It's open source just like the Algorand Wallet is. And we're going to go through it in depth later, but this is the overview. And with that, by us combining the Algorand Wallet with this WalletConnect protocol, we are allowing dApps to have the option to sign transactions via not only your desktop, but also mobile. And that's what I've been talking about this whole time so far. Now dApps will be able to connect to a user's wallet, Algorand Wallet, and send them those signing requests in this really intuitive user flow, in that I'm on the dApp, I hit a button, it sends it straight to my wallet, I can review, and then I can sign and send it back. Ideally, this is not only does this grant dApp developers access to the large user bases of Algorand Wallet and MyAlgo from the teams at Rand Labs, AlgoSigner, those kinds of things. Now we have all these connections within the Algorand ecosystem. And so every dApp has multiple options. Algorand Wallet users now have multiple options to go to when they're trying to sign transactions or potentially do various things in DeFi, that kind of thing. And then finally, it's what we would love to have is a potential dApp browser, or at least a list of integrations where a wallet user can go into their wallet and say, okay, I want to see a list of all of the integrations or all of the dApps that support this Algorand Wallet, which would be a really nice experience for them to just click to tap on a link, and it would take them to a dApp, and then they can interact with really seamlessly. Excuse me. So here's the step-by-step flow of what this might look like. I alluded to it earlier, but I'll just go through it again at a high level. So the first thing that needs to happen, again, is this connection. And the connection is, I guess before we even start the connection, the dApp needs to have a transaction or set of transactions that need to be signed by a mobile user. And so once the dApp has that, okay, I have these transactions, I need them to get signed. The dApp then presents a QR to begin WalletConnect session. And once that happens, in that process, the Algorand Wallet user scans that QR, and now the wallet and dApp are now connected. And I do want to say that while I won't talk about it in these flows, it is possible to do this all on your mobile phone too. We can do it through deep links and via those sort of connections. But for now, we're just talking about desktop to mobile. But I do want to just mention that it is possible to go mobile wallets, Algorand Wallet, to a dApp in your mobile browser, just so you know there. Okay, so now that the connection has been created between the dApp and the wallet, the next thing is for the dApp to actually send a request to sign one or more transactions to the wallet. So they bundle up their transactions, they send it over to the wallet. The wallet then gets a notification. They review the transactions coming from the app. It'll list it. And then after reviewing them, you can look at all of the fields. You can even review the raw JSON. And then once you hit confirm, the wallet sends those transactions back to the dApp, who can then broadcast them to the Algorand blockchain. So again, at a high level, it's the connection, it's then the request, and finally, it's the Algorand Wallet Algorand Wallet user hitting confirm, which signs the transaction and sends it back. The cool thing about this is that your private keys, they never ever leave your phone, and they're just as secure as you signing transactions from your mobile wallet. Here's a little bit of a contrived user flow. I was just trying to think of applications that could be fun to show with this. This is an auction site. We're going to pretend like eBay is powered by a blockchain. And what we're doing here is I just want to show when in your user flow, in your dApps user flows, would you start this connection? So there are a couple of places you can do it. One is on account creation. You can think of this as, okay, I'm going to put my name in, Ian Cross, here's my email address, all of this stuff. And then on the next screen, maybe it says, do you want to connect a mobile wallet? Similarly, it would be, do you want to connect a payment method or something like that? Then you can show the QR, then you can start this session. And sessions, we'll get to this in a second, but sessions can last for basically as long as you need them to. I will say that there are also mechanisms for canceling a session. Keep that in mind. But at this point, it's like, okay, I've created an account. I also now have my Algorand wallet, which is connected to this account. The other way you can do it is let's say that there was just a button here, I guess we'll go to the next screen. So now that my connection is created and my wallet is connected to my eBay, in this case, account, I can, when I go and actually check out, when I want to pay, that's when your dApp would send that request over to your Algorand wallet for you to confirm that transaction. So over here, I don't know if you can see my pointer, but the numbers are wrong. Just pretend like this would be the same number over here. It would say, okay, it's coming from eBay. It's going to be taken from this account, this asset, all this stuff. Once I've verified it, I can scroll down. I can even see the raw JSON, as I mentioned before, and I can confirm and send that over. If you didn't want to go through that, again, this previous screen, if you wanted to, say, present the user with a QR during their payment, you can also do that too. You can say, all right, ready to pay, and then you say scan this, and then we'll send you a request. So you can also do that immediately. The session is just another option if you think that they'll be using, the user will be coming back with lots of transactions or things like that. But of course, one-time transactions are totally fine too. And like I said before, the dApp can leave the session open for as long as they want, but the Algorand wallet user also has the power to remove a session, because let's say maybe they stopped using the application, maybe they were getting too many requests or something like that. It's super simple to just go here. This is just a mock-up for now, and I just threw eBay on there, but there are 3 dots here. You'll be able to just tap those and remove the connection. And you can just start it back up if you want to. It's as easy as scanning a QR. So before we get into the demo, I just wanted to highlight that a WalletConnect request is really just an array of transactions. So this could be one or more transactions, and within that transaction array, you can also have transactions within the same atomic group. So that means in this example, I have a request to sign. We have 4 transactions. The first 2 are, maybe the first one is an asset opt-in, maybe the second one is a payment transaction, and then the third and the fourth are in an atomic group, maybe doing something similar. And right now, each of these transactions can be either a payment transaction, asset transfer, asset opt-in, app calls, or obviously what I just mentioned, atomic transactions. What we've found in doing some of our user research and talking to various partners, some of which might be on the call today, these get us pretty far as what you need as having users sign these types of transactions. Some things that you'll notice aren't on here are things like some certain asset ASA management functions, such as asset clawback and configuring those types of things. We're more than happy to include those in a later version. All you need to do is just ping us and be like, hey, this is my use case. You're not really handling it here. And we can absolutely include that in the next version. It's just that these were the main ones we want to get out there, because a lot of the dApps that are either built or currently being built are using a combination of these. As an example, maybe I think in the last office hours, AlgoDex was talking about their arrays of transactions that needed to be signed. So that would be an example of something that could use this format. Okay, with that being said, I just want to let you know that, again, we're going to continue. This isn't a, hey, we're putting this out there and we're stopping work on this. Again, we want to keep building out this functionality. We just want to get something out to you as quick as possible. And yeah, so there are a bunch of links on here on this slide that you can go to at your leisure. But I want to highlight one particular one, which is at the very end, which is the Discord channel. If you aren't already there, you can follow that link and check out the Algorand Wallet channel, or just general dev on Algorand. If we monitor it frequently, but if we don't get back to you, I promise you a community member will. Yeah, check it out. But
all right. So thanks again, Ian, for that presentation, for the background about WalletConnect and how we're going to be supporting it on Algorand. I have right here a live demo to show everyone with both an example dApp and a development version of the wallet that I have on my screen here. And I will show you an example of how this is going to work in the wild with actual applications and wallet users. So the first thing, as Ian was talking about, that we need to do is establish a session between the wallet on my phone and the dApp that in this case is on a website, but it could be another mobile app. It could be something else entirely. It could be a command line application. There's really no limit to what the dApp can be. And the first thing we're going to do is, for this example, I'll hit connect to WalletConnect, and I will get a QR code to scan. And I will do that right now, just to see. Yes, okay. And so this is the screen I'm presented with, and it basically tells me the website that the dApp originated from. And it's asking to establish the session with my wallet. And so I can click here and choose which account that I want to use for this session. I only have one right now, so that's an easy choice for me. And then I can either click cancel to reject this or connect to establish that session. And so I hit connect, and immediately the dApp on the left responds. At the top right corner, you can see my address. Let me go back to the main page. This is the address of my account that I'm using here. So the dApp gets told this address, and then it can go to the chain and fetch more information. And so in this balances section, the dApp has fetched from the chain all of the assets that I have and their balances here, and it can display them to me. And then the interesting part are these action buttons. So we've been testing with a lot of different scenarios just to make sure that the right thing happens every time. And I'll show you the first one, since it's the simplest transaction that you'll need to sign. And this is just a single payment transaction to another address. And so what's going to happen is when I click this button, the dApp will send a WalletConnect request through the bridge server, and that will reach my phone who's listening for requests, and it'll pop up a request for me to sign. So let's try it out. So I hit this loading screen appears, and then on the right, my phone receives a notification to sign a transaction, and all of that information is here. So the firm address is the address of my account. The asset is Algos. The to address tells me who the transaction is going to, as well as my current balance, the amount of this transaction, and the current fee that's on that transaction. There's also a note value. It's just example note value right now for this transaction, but this would be whatever the transaction note is populated by the dApp. And if I really want to drill in and see more information, I can hit this show raw transaction button at the very bottom. And this will show me the JSON representation of that transaction. So if I really want to verify every single field, even the ones not shown on that overview page, I have the ability to do that. I can see the first valid, the last valid round, and more information about the transaction there. You can also copy and paste this anywhere else that you would need to. And so this all looks good to me. I'm happy to sign this transaction. So I will hit confirm, and that will get sent back. Sorry, that will first sign the transaction and then send it back to the dApp. And you can see it already has the response over here. As I said, again, this is just a demo. What it's really doing is showing me the transaction ID of the signed transaction, as well as the signature right here, which is great for testing. That's all you would need to do. But we can also submit this to the network and actually have the transaction be committed into a block. So I will do that. It is submitting right now. Should take a few seconds. There we go. So this transaction was confirmed on testnet in this round, which is great. I think if I use the block explorer to search this, it will be committed there. And on the right, as you briefly saw, I got the notification from my wallet that the transaction was submitted as well. And so, yep, this top one right here is actually that submitted transaction with the example node value too, which is really cool. All right, I can show you also what happens if you decide you don't want to sign a transaction because something doesn't look right, or you've changed your mind after initiating something on the dApp side. So I'll hit this button again to do the same thing. I will get another transaction signing request. And if I decide I don't want to sign this, I'll hit decline. And that will send back a message to the dApp that I decided not to sign the transaction that I was presented with. And so here it just shows a message that the request was rejected. And yeah, that is the basics of the demo. We're still working on more of the complex use cases to make sure that everything happens as it should be. But this will allow you to not only send algos, but also send assets. It'll let you opt into applications, make application calls, and the really cool feature, which I think is exciting for a lot of people, is atomic transaction groups. With WalletConnect, I could make a dApp that essentially does an atomic swap, where one user signs one transaction from a group and the other user signs the second transaction, and then the dApp puts them together to actually execute an atomic swap on the network, which is really cool, and a feature that I think up until now, the Algorand Wallet has not been able to support.
Jason,
Hey, Jason,
a question on that
Sure.
demo. It says he tried running this demo, but it kept saying that the QR code was invalid. And that was I gave him the link to the Algorand Wallet Connect example that is on your GitHub repo.
Hey,
Jason?
Russ, I can step in on this one. I saw a couple of other questions relating to this too.
Okay.
So right now, Jason is using a demo app that is not, this doesn't currently exist in production. If you are a dApp developer and you are interested in building this out, we have a limited number of beta spots, basically, where we can send out this test version. So you can feel free to get in touch with us either via Discord or reaching out to us personally and tell us about your use case, and we'd be happy to send you over the demo version. I just wanted to make sure I called that out because I saw a couple of people asking about how to actually do this with that with the prototype that Jason has built here.
Right.
Thanks.
Awesome. Well, if people think of more questions, feel free to add them to the chat. Ian, please stop me if there's a question. I'll try to answer it.
Sounds great.
But now I can show you some of the code behind this and what you would want to do if you're a developer and you want to add this functionality to your dApp. Like Ian said before, we're still working on adding some features to our SDK to make this simpler. So I wouldn't recommend necessarily copying all the code that I'm going to show you, just because it's a little more verbose and more complicated than it needs to be currently. But the ideas will be transferable 100%. This example dApp that I have here is live on GitHub, and I believe this is linked from Ian's slides as well, if you want to check this out. And this is actually a fork of the WalletConnect example dApp, which is very similar. It lets you try out WalletConnect on Ethereum and do a few kind of sample transaction signing events there. This just has a forked version to be compatible with Algorand and all of our specific transaction scenarios and information. And so because this is forked from a different repo, it's more complicated than it needs to be. Like, if you're interested in the code, definitely check it out. But I will also show you a slimmed down version of this that has just the important parts for WalletConnect. Before I do that, I will first show you this page in the Algorand Foundation's ARC repo. And so this is a page that describes the schema for a general transaction signing API. And the goal behind this API is to support any type of transaction signing in the Algorand ecosystem. So this could be using Algo Signer, it could be using a different wallet, or it could be using WalletConnect with the official wallet, as we did today. The goal is to capture all those use cases and just have one standard there. And so for WalletConnect, we are following this standard very closely. I would recommend reading through this if you have questions about the specific things that can and can't be supported, because this will have all of the details about what can be supported and how to format specific transactions. And it does get a little bit complicated once you go into all of the different possible combinations and use cases for transaction signing. So it's a good resource, but it is pretty verbose. And so the goal of adding things to the SDKs will be to simplify the process of creating structures like this that contain information about how a transaction should be signed and who should sign it and things like that. And so that is coming soon. We'll be sure to, I think, message on Discord when that's available, if people want to check that out as soon as possible. Otherwise, I have this slimmed down Algorand WalletConnect example that's very basic, but just will show you some of the components and the ideas that you'd need to actually integrate with WalletConnect and Algorand yourself. And so, the first point I point out first, this is just a Node CLI application. And there are two important things it depends on. One of them is the Algorand SDK for JavaScript, and the other one is the WalletConnect SDK. So you'll need to use both of them if you want to sign Algorand transactions with WalletConnect, just because WalletConnect is needed to actually interact with their core protocol and their ecosystem with that. And so besides that, there are two folders in the source. Client corresponds to a wallet that will be receiving and signing transactions, and server corresponds to a dApp that is sending out transaction requests to be signed. So I will open up server first, since that's the important one. And I'll show you this CLI file, which is here. Let's make this bigger. I will put the wallet away for now. Okay, so this is going to have some basic code to actually create and send out transactions to be signed. And so the first thing that happens is we create this Algorand WalletConnect server, which has a WalletConnect bridge server to use, and then some information about the dApp that's actually going to be sending out the transactions. So you can have a description, the URL for the dApp, some icons, and a name. And then you will call server.new session to actually create a WalletConnect session. And this corresponds to the QR code that was shown earlier by the example dApp. I'll just show it again. This one right here, this is essentially creating a new session for us. And so we get the URI that corresponds to that session. You can feel free to encode this into a QR code for the wallet to sign, but the wallet will also support clicking on a URL and actually initiating a session like that, which is useful if you're on your phone with your wallet, and there's also a dApp that you're either accessing from a web browser or as a native app on your phone.
You just hit on a question that someone had. I know we talked about it briefly, but can you just talk? So the example I gave in the slides was a desktop, like web app to phone. Can you talk about what it looks like for the phone if everything you're doing is on your mobile device?
Right. Currently, how that works with the WalletConnect ecosystem is if I were on my phone and the website detects that, when I click connect, it won't show me a QR code. It will instead show me both, I think, a URI that's a link containing the same information as the QR code, but also it has a bunch of icons for supported wallets that you can click directly, and that will deep link into a wallet that you've installed on your phone. And so if you're on a mobile device for all these stages, the high level concept should be the same. You just want to actually scan a QR code to do that.
Yeah, exactly. So instead of the QR, you would just see a list of WalletConnect compatible apps.
Yes.
And you would see Algorand Wallet in this case, but you might also see MetaMask or others that support this this connection. And so that's how you would do that. So it would just be basically switching from your Algorand Wallet app to the browser and then back, or vice versa.
Yes. And I think this might be where down the road, having like an integrated dApp browser in the Algorand Wallet might play into it. It'll kind of make that process easier to find dApps from your mobile device only. Okay, so continuing where I left off, you can call this session.onConnect function, which will wait for an event corresponding to the wallet actually initiating the other half of that session and sending you the accounts that it wants to share with the dApp. And so here I'm just locking out a peer connected with the accounts, and this will be an array of accounts that they connect with. And then I have some code here that basically waits 1 second, and then it creates a transaction just like you would currently using the SDKs for Algorand. You can create the transaction that you want. I'm using the result that I got from this OnConnect function that contains the accounts that the wallet has shared with me. So I'm making this the sender of this transaction, but I can feel free to modify any other fields here. And then basically I'm just logging out that I'm asking the client to sign a specific transaction. And then I'm using this function called sign transaction to send this over to the wallet with this message, please sign this transaction. And then this will wait until the wallet either confirms it on their end and signs the transaction and sends that back, or they reject it because they decline the transaction because they don't want to sign it. And this will just print out, if successful, this will print out a base64 version of the signed transaction that's ready to be submitted to the network. This doesn't actually submit it to the network for this example, but you could do that right here. And that's pretty much the important part of this example. I will show you more of the code in detail a little bit. This just handles a few other cases of on update means the wallet can technically update their addresses that they're sharing with you. And so this is handling that. And on disconnect will be called if the wallet chooses to end the session early. You'll get a notification for that. And so this is the high level stuff that you would need to do to integrate with WalletConnect. I will show you there's like a helper file called server.ts that actually integrates with the WalletConnect SDK and does some of the heavy lifting there for the example here. I've got some types. I just want to show you a few parts here, and so this represents a single session, and we're integrating with the WalletConnect SDK to actually do this. So we're creating a new object here. We're returning the URI from there, having some stuff to create a session, and listening for events and handling them here. I think the interesting part that I wanted to show is these two functions, sign transaction and sign transaction group. And so I just showed you someone calling sign transaction, which takes an Algorand transaction, an optional message, and it packs it in the right way, in the right format to actually send over the WalletConnect protocol. And so this is just a thin wrapper around the sign transaction group function. And this does some more complicated things. It basically encodes the unsigned transaction to base64. And then we figure out who should sign the transaction. So if you are sending over an atomic group of transactions through WalletConnect to your phone to be signed, it'll probably be the case that you don't want that wallet to sign every single transaction. Think about the atomic swap situation that I was talking about earlier. I might want only me to sign the first transaction, and then my friend should sign the second transaction, or maybe the dApp should sign the second transaction and submit that if I'm doing a trade with it. So some transactions will be tagged as essentially not to be signed by the wallet. And these are only there to complete an atomic group to show you all the transactions that are in there, even though if you only have to sign one or two of the transactions in that group. So if people have questions about that, I'd be happy to answer more. But otherwise, I'll carry on. Sure.
Hey, Jason, there is a quick question. Maybe you can just talk about the languages used here and potentially what languages you would use when implementing something like this.
Right. So I think your main bottleneck will be which languages WalletConnect libraries have been written for. So definitely JavaScript is supported. They also have libraries for Swift and Kotlin, which doesn't perfectly align to our SDKs, but we do have a Java SDK that I think you could use with their Kotlin one. But however, if there is a WalletConnect library for either Go or for Python, you'd be definitely able to integrate with them and using the corresponding Algorand SDKs too. Did that answer the question?
Hopefully. We'll see soon enough.
Feel free to follow up if that can be more specific.
And I think actually maybe a follow-up question, Jason, that you could talk about is what a transaction actually looks like. If someone already has a dApp that they've developed and they already are keyed into the Algorand ecosystem and they use transactions, do they need to do any additional work in packaging this or anything like that?
Yeah, that's a really good question. I was actually just about to get to that next.
Oh, nice.
So that's good timing. Great. And so what I'm trying to show you here is essentially how to convert this, I guess not in this example, an array of Algorand transactions, but essentially an array of Algorand transactions into a format that the WalletConnect protocol and specifically our transaction signing API will accept and will work properly. And so right now the process is just to have custom code like this, unfortunately, where there are interfaces that have descriptions about what fields should be populated and how they should be populated, such as the base 64 encoding of the unsigned transaction. And you can optionally add an authorizing address and multisig, a bunch of stuff like that. But because this is an evolved process, this is the part that we're going to be adding to some of the SDKs that will help you build up a transaction signing request just from existing transactions that you would already have in a dApp. So this part is definitely going to be improved. I just want to show you some of the broad strokes here about what's happening, but know that there will be a simpler way to do this in the upcoming weeks, right? And so the last part that I wanted to show is essentially finally bundling this up into the proper format and then calling, this is a WalletConnect library method, send custom request, that sends out the request as a JSON object to your wallet to be signed. And so the WalletConnect libraries, at least version 1 of them, they have built-in functions for Ethereum signing. But of course, since we're signing an Algorand transaction, you just have to call this send custom request and do a little bit more of the formatting before putting it into that, which hopefully the SDK will be able to help you out with very soon. Right? And so that's pretty much everything I wanted to show. Again, for this stripped down example, the server is the dApp, and so that's the important part. This client folder essentially corresponds to the Algorand Wallet implementation. So it's not very important to understand that unless you want to add WalletConnect support to your Algorand Wallet that you already have. Then this is useful to check out. All right, so that's everything I have. Can you have a dApp that is able to handle both Ethereum and Algorand clients? Meaning, if you join with an Ethereum wallet, sure, I'll send you an Ethereum transaction to sign. Otherwise, I'll send you an Algorand transaction to sign. That's totally possible using WalletConnect. You would just have to be able to support both Ethereum and Algorand in your dApp, but that should totally be possible.
I'll just say that we're excited about this. This is a small step in one of many that we're going to take to make sure that we support dApp developers. And hopefully you guys see the benefits that this sort of unlocks. And we're excited to see what kind of dApps you guys build or what kind of integrations those look like. So, yeah, thanks for having us and thanks for listening.
Great.
Definitely. I echo all of that. And thanks everyone for coming who's interested in seeing this.
We all really appreciated today learning about connecting your dApp to the official Algorand wallet for native mobile signing capabilities. I think this is something that a lot of developers have been looking for. I know a lot of our demo code, we have the key hard-coded in the sample, and we always put comments in there, not for production use. And so this is really a great way to get around that problem of keeping your private key secure and yet doing these transactions that are initiated elsewhere. So very cool stuff. Thanks, guys, and we'll call it a wrap here today. Thank you very much.